All right, guys, so we're continuing on with chapter 11. Now, what we're talking about today is areas of polygons. And we're mainly going to look at kites and then polygons in general. Now, the area for a rhombus or a kite is 1/2 of the diagonal 1 times diagonal 2. So the area is equal to 1/2 of each of the diagonals multiplied together. And a diagonal, again, we've covered it multiple times, is the line that goes from vertex to vertex, opposite vertex, and makes a straight line. So our diagonal 1 and diagonal 2, we multiply those two together and then divide it by 2, or we can say that we multiply it by 1/2, and that will give us the area of the entire shape. So if we look at this here, we want to find the area of this rhombus, and we know it's a rhombus because all four sides are congruent. Well, the area is equal to 1/2 of diagonal 1 times diagonal 2. Now we just need to see what our two diagonals are. So one of the diagonals would be 8 and the other would be 6. Because this entire distance is 8 and this entire distance is 6. And now we can multiply these together. Well, what's 1/2 of 8? 4 times 6 is? And if we want to include our units, it would be meters squared. Because whenever we're talking about area, we're always talking about square units, whatever the units are. Square meters. Any questions on any of this here so far? So this one here is a kite because we have two sets of consecutive congruent sides. But its overall area is going to be the exact same. 1/2 of diagonal 1 times diagonal 2. So if we look at this here, what would our two diagonals be? 7 and 10. And we can multiply these together however we need. So if we look at this here, 1/2, well, we can do 7 times 10, which is 70. And 1/2 of 70 would be 35. And this here would be centimeters squared if we're going to use our units. Or we can type it all in the calculator. Either way works. Any questions on any of this here so far? We good with this here? Awesome. Again, we have a kite. So how can we figure this out? 5 and 11. Well, if we're doing this by hand, 5 times 11 is 55. And if we divide this by 2, we should get 27.5 what? Feet squared. And that would be our answer. Any questions over this here? Does anybody know why we call it feet squared, or we say these units are square? Besides, that's what we do for area. Y'all know the reason why? Well, I'm going to rewrite this. Because our two diagonals are what? One of them is not just 5, but it would be 5 what? 5 feet. The other one is, well, we'd have 1/2 of, well, 5 times 11, as we already said, is 55, yes? Well, I have units with it, don't I? Feet times feet. Anything times itself is written as squared, so we can say that this is feet squared. Because we can treat the units as a variable because they are describing it as part of the units. Because we're multiplying feet by feet, which would give us feet squared. That's kind of the reasoning behind it. Are there any other questions over these kites and rhombuses, or do we feel comfortable with this here? Yes? Feel good with this here? Okay. If we feel good with this here, we'll move on to polygons. Now, the main way we solve polygons, and we're mainly going to focus on regular polygons because it's going to be a little bit more difficult if the polygon that we're trying to find the area for is irregular. Not all the angles are the same, not all the side lengths are the same. It's a little bit harder to find. But what we do is we take this polygon and break it up into triangles. We break it up into different triangles. And so for a hexagon, we're going to have 6. Octagon, we would have 8. Nonagon, we would have 9. And we can find each area of the triangle and add them all together. It's really how we go about finding it. Now, let's see here. Let's make we have a hexagon. Nope. So we have this line here, and I'm going to break it up into, if I can move this line. There we go. Here. And here. Now we have all of these lines here as our different triangles. And what we're going to do is we're going to drop a line down, straight down, so that it makes a right angle with the other side. So that I can find the area of this triangle, because for the area of a triangle is 1/2 the base times the height. So this would be our base and this would be our height. Now specifically, the height in Polygon is actually called the apothem. The apothem is a line that goes from the center of the polygon to the side and makes a right angle with the side. It's perpendicular to the side length. Is what we call the apothem. And each one of these angles, interior angles that we make up here, are actually given to us by a set formula. The 360 divided by the number of sides. So here, since we have 6 sides, we can do 360 divided by 6, which would tell me that this interior angle is 60 degrees. And we can find that with any number of polygons. So any questions on this here so far? We kind of good with this here? And we'll delve back into this here in a minute, but we're mainly going to focus on the angles first, and then we can see how we get the formula from it. Now, in this diagram here is a regular polygon, a regular pentagon, and we want to find each of the angle measures. So if I want to know each of the whole angles, these interior angles for this polygon, well, AFB, this whole angle here would just be 360 divided by the number of sides, which is 5. And what's going to be 360 divided by 5? 70? 72? So each one of these interior angles is 72 degrees. Now it works out, so this entire angle is 72 degrees. Now our apothem is an angle bisector. So what does that tell me about the two angles inside of that triangle? So this angle here is going to be what? Because what does an angle bisector do? It cuts it in half. When we talk about bisecting something, we're talking about cutting it in half. So the apothem will always cut this angle in half. So GAF, so GFB and GFA, both of these here are going to be 36 degrees. So really inside of this polygon, we do have a triangle that's 36, 90, because we've broken it in half. Any questions on this here? Well, if I want to find the other angle, the other one is 54 degrees. Any questions on this here? Any questions on anything we've done so far? And I believe we only have one more of these, kind of looking at these angles, before we start actually looking at the formula. Now, in the diagram, polygon ABCDEFGHJK is a regular decagon. Well, decagon has how many sides? 10. So if I want to know what this overall angle is, well, we can take 360 and divide it by, and hopefully you can do this without using a calculator, 36, because we dropped the 0. 36 degrees. So KPJ, the whole angle would be 36. LPK would be 18, because that apothem is going to bisect that angle. It's going to cut it in half. $90 minus what? Which would give us 72 degrees, because really the triangle that we're looking at, PLK, angle L is going to be 90 degrees. P, we found out, is 18. X, all three have to add up to be 180. Or since it is a right triangle, our two acute angles have to add together to be 90. Any questions on this here? Manipulating triangles. We feel good with this here? Okay. I'm going to come back to this here and explain why this is important. We're not going to really, we'll utilize it a little bit in finding the angles, having you find the measures, but we're not going to use it in having you find the area, because this is important in finding area. Now the area formula for a polygon, area is equal to 1/2 of the apothem times the perimeter. 1/2 of the apothem times the perimeter. Or 1/2 of the apothem times the side length times the number of sides. And there's a reason we get this. Let's call it, instead of base, I'm going to work through this. Now, as I said earlier, we're really breaking this polygon up into triangles. Yes? So the area of one of those triangles would be 1/2 the apothem times the side length. So that would be that triangle there. So we have 2, 3, 4, 5, 6 of them. Side length times the apothem plus 1/2 the side length times the apothem. 1, 2, 3, 4, 5. Need one more time. Right, because I've got the same thing multiplied by itself 6 times, yes? So we really have this here, 1/2 the side length times the apothem times 6 for this here. Well, the side length times 6, well, this is the same as the perimeter. That's the same as the perimeter. So we can say 1/2 times the side length times the number of sides, or 1/2 the apothem times the perimeter. Either one of them is actually going to give us the same thing, because it is our same answer. So let's look at this first one here. Now, they didn't tell us what the perimeter was, so we'll need to do 1/2 the apothem times the side length times the number of sides to really solve for this here. So when we look at this picture, what is the apothem? 14.4. What's our side length? How many sides does it have? 1, 2, 3, 4, 5, 6, 7. And we'll just kind of like with our rhombuses and kites, we can type all this into the calculator and have it figure it out for us. Does everybody agree with 756? 756 hundredths. Do you agree with that number? Does anybody know what the U stands for? Units. Yep. If they don't give us units, we'll put that there. I'm not going to be as big of a stickler about units, but especially if you do hit a teacher that does, they will start counting off. Any questions on this here? So again, we're looking at a polygon. Polygon area is equal to 1/2 the side length times the apothem times the number of sides. So what would our apothem be for this here? 14.5. Side length is? 1, 2, 3, 4, 5, 6, 7, 8. What? Sweet. And if we needed included units, it would be units squared. Any questions on any of this here? Any questions on anything we've done so far? We good with these here? Yes? We'll skip a few. Let's look at this one here. Because I want to look at this one here and we'll look at the next one and then we'll go back a bit. Okay, stay. So our apothem would be what? 5 square root of 3. Our side length. The number of sides. So we just have to plug it in. And we would forget. And it's going to be an ugly decimal because of the square root of 3. The square root of 3 is an irrational number. It's a non-repeating, non-terminating decimal. Any questions on any of this here? Any questions on anything we've done so far today? We good with this here? Yes. So really, when we look at this here, if we have the apothem, the side length, and the number of sides, we could really find the area. Yes? Okay. Let's find, let's say, let's do 8. Reed, give me a number not bigger than 12. 8. We want to find the area of this here. Now, it is possible to actually find this area, to find the area of this octagon with a side length of 8. And this is all I really need. This is all we actually need to find the area of any regular polygon. We just need the polygon itself, its number of sides, and a side length. Now, as we said when we started talking about this, really, we're breaking this figure up into triangles, yes? And I need the apothem, this line that goes from the center up, yes? Now, we didn't deal anything with their kind of central angles, but the central angles for an octagon, you would be taking 360 and dividing it by 8 because it's an octagon, not because its side length is 8. And 360 divided by 8 would be 45 degrees. So the old angle would be 45, and the smaller angle would be 22.5 degrees. So are we okay with this here so far? Because really what I'm doing and what I'm using this for is to find the apothem. Because if I can find the apothem, then we can actually finish out the formula. Because so far for our area formula, 1/2 the side apothem, which we don't know, times the side length times the number of sides. We have almost everything. We just need that apothem. And we've somewhat created it. Because what we have here, and what I've created is a triangle, right triangle, with an angle of 22.5 degrees. Now again, this is an angle bisector. It's also a segment bisector, which means this top part is 4. The apothem, we don't know. So are we still good with this here? Do we have a way to find that value for the apothem given an angle and a side length? Tangent. Because tangent of 22.5 degrees is equal to the opposite side length over the adjacent. Now to solve for the value of x, we would multiply both sides by x, telling us x tangent of 22.5 is equal to 4. So it tells us x is equal to 4 divided by tangent of 22.5 degrees. Any questions on this here so far? Now this is the real key of why we have those central angles and why they work the way that they do, because they're helpful in us finding out what the apothem is. So for us here, 9.656 times 8 times 8. And actually now we can find the overall area by plugging this in. And this works for any shape. get a 309 point. So our area for this here would be 309.019336 more closely. I used the actual full decimal for the Apothem. So when I plugged it in, I didn't plug in 9.656. I actually plugged in 4 over tangent of 22.5 because it'll give us a closer approximation of the value. But here, that's going a little bit farther than what we're actually going to cover. Because I wanted to show you this here so that you can see that we can actually find the area of a polygon, a regular polygon, with just a side length, if we know what the polygon is. But